Thanks for having me here today. I'm actually a consultant with Habitat Management, and I'm going to be talking to you about a case study of a project we did with the Cocopah Indian tribe down near Yuma, Arizona. Just to get you started, the Cocopah Reservation is split into 3 different pieces, and our project area was right on the West Reservation. This is the international border between Mexico and Arizona. So this region of the Colorado River is called the Revegetation. And so we're working right on the river there. It is about 5 miles south of the Morelos Dam, which is the last dam that's right there at the Northern International boundary. So this is our project area. It's about 40 acres. And like I said, it's right there on the river. However, this area has a pretty incised river channel. The water is in the river. It's probably 20 to 30 feet below the area where we were working, even though we were working only about 300 feet from the river, actually right from the river up to about 400 feet away from it. So we've got an incised channel, we've got a pretty depressed water table, and the last flood prior to our project was in 1993, although we did have a flood the year after we did the planting, which kind of made for some interesting results in this project. So the Cocopah Indian tribe had a couple of goals with this project. I should say they got a grant from the Arizona Water Protection Fund to do this work, and a small grant also from the National Wildlife Federation. And then they hired us to help them with developing a re-veg plan and implementing that. So basically what they wanted to do was create a more productive native habitat. They wanted to establish some of the species that were of cultural significance to the tribe. And also they wanted to try and make the river accessible again to the tribal members and the public in the area. So the objectives here were to develop a revegetation plan based on the conditions, remove what Tamarisk was remaining. There had been a project done to clear some of it earlier, revegetate the 40-acre area, and then there was money in the grant to do some monitoring for 2 years. So I'm going to talk to you about the first 2 years of data. The project was actually started in 2008, and so the data I have is from 2009 and 2010. If you're not familiar with this area, average annual precipitation is less than 3 inches, so we've got a pretty desert situation. And also, we did our planting in April of 2009. This red line is our 2009 precipitation. From April of 2009 until January of 2010, when we got quite a bit of rain, we got only about a half an inch of rain. So the first 9-10 months that after we did the project, we had no precipitation at all, which kind of it ended up being a weird project because we had this very, very dry year followed by a very, very wet year, more than double the average annual precipitation. So the first step in developing our re-veg plan was to go out and look at the site, see what was there, and try and come up with a plan that was going to be really specific to this site. So we went out with handheld GPS and we mapped the current vegetation on the site before we started. So what we had was some areas where we still had some pretty nice cottonwood stands. Didn't want to mess with those areas very much because we had pretty good cottonwood establishment and actually not much tamarisk in the understory. We also had some areas that were dominated by arrowweed, which is and this is a species that is important to the Cocopah tribe in some of their cultural practices, and so they really wanted to promote this species if possible. I have not yet found a source where we can buy seed for it, so the goal was just to not disturb what was there and hopefully be able to enhance that development. And then, of course, we had a lot of areas that were dominated by tamarisk. The site had been cleared previously, and so there were mostly reed sprouts, that were usually 4 to 6 feet tall. So we looked at the vegetation, then we wanted to look at what are our groundwater conditions. Like I said, the river channel is very incised there, so even though we're right next to it, we didn't know how deep our water table was going to be. If we tape measure down there to see what the water table was doing. We did that in 15 locations, and then we used some interpolation software to create some ice maps. So this map on the top is the maximum depth, the deepest water that we saw during the 7 months, and this is the shallowest water. So basically, we determined that the only area where we could potentially plant poles was this northern end, where the water never got deeper than 10 feet below the surface. We also took a bunch of soil samples. So we don't want to be, maybe we've got good water table, but we don't want to be planting cotton where the salinity, pH is way too low. So we took composited soil samples from a number of different areas. We ended up sending in about 35 samples from 40-acre area. And then we were looking at our results. So we wanted to look at the soil chemistry. If we want to plant cottonwood and willows, many of you probably know all this stuff, but we're looking for this range here. We want a pH that's less than 8. Electroconductivity is a measure of salinity. We want that to be less than 4. And then we also don't want really sodic soil either. So in the areas that were good, we could plant our cottonwoods, our willows, assuming that we have the water. And then we had some areas also that we left bare, and these are the willows, the areas where we probably couldn't plant those species, but we can still establish a number of other native species. So when we look at our whole site, these are the areas that we did our soil sampling in. This is looking at our pH. Again, the pH was good up here, so we planted those cottonwoods and willows. We had a fair pH down here as well, but our groundwater was down there. So the same thing with salinity. Wasn't quite as good, but we determined that we could probably still get the cottonwoods to establish willows up here in the north end. But then we also looked at texture in some research that I did with Anna Scher. We found that the pole establishment was best if our sand content was not too high and not too low. So looking for a percent sand in the soil, 40 to 70%. And again, we had that up in this area. So that's the area where we were going to plant cottonwoods, willows, and then the rest of the area we determined was just going to have to be up in the seeding area. So like I said, we did the tribe had done some additional mechanical control with money from the U.S. Border Patrol back in 2004. And so in 2009, we came in and removed all the rest of the re-sprouted Tamarisk. And then we did also do herbicide treatment. The grant that we had also had some money for some follow-up treatment, so we did start applications of herbicide in February 2010 and January 2011. We also have the re-sprout. So looking at our re-veg plan, kind of broke the area up. The area in purple here, the area that we determined that we could plant cottonwood poles in. The area in blue was going to be willow poles. The area in green here had a really shallow water table, so we decided we could try planting gallon containers of mesquite. And then the rest of the areas were just seeded. We had 3 seed mixes. We just did sort of a lighter seed mix in those areas where we had the cotton showing, and then the areas that were bare, we did heavier seed mix. Another challenge of this site is that it's actually on the wrong side of the U.S. Border Patrol's vehicle barrier. So the U.S. Border Patrol manages a stretch of the road on the stretch of the river, even on the tribe's land, because this is the international border. And this vehicle barrier has been set up on the first levee. So in order to do work on the other side of it, we had to be kind of creative about how we were going to get our equipment in. So we developed this ramp that we could take a track skid steer over. At one point, we did also lift some equipment over the plane. So to plant the poles, we used the skid steer on the 9-foot thing on it, 3 inch diameter, and we filled them until we hit wet soil. We were hoping to be able to go down 10 feet. We actually had start to construct this one. So after we drilled the hole, we put the hole in. These were locally harvested about 20 miles up the river. Cottonwood poles, and they were kept flat until we planted them. They were backfilled by hand. They were watered in at the time to get good soil contact, and then we watered them about 2 or 3 weeks later. Once again, and that's all the water they got, unfortunately. There's sort of a map of where they ended up going. We put in 700 total cottonwood poles at an average density of 75 poles per acre. We also mentioned, I mentioned that we planted some shrubs, put in 2 species of mesquite, and we also put in some desert willow to try that out. And again, that was about 100 plants per acre. We were expecting pretty high mortality, I would say, on both the plants and the shrubs. In order to save the area, because we did have quite a bit of vegetation and we had that access limitation, we actually hired a local crop buster to spread the seed and fertilizer with a big string aircraft. It was GPS controlled, so he was able to load all of those polygons into the GPS on his plane and actually apply the seed and the fertilizer quite accurately. We did tests with tarps and found them to be really quite accurate. We did spread fertilizer based on some of our soil results. So pretty much the entire area received 200 pounds per acre of phosphorus. The blue areas also received some nitrogen, and the purple areas also received some potassium. And then all of these hatched areas, we added some biosol, which is just a organic fertilizer that has 70% organic matter in those areas in soil. We thought maybe that would help to give the seedlings a boost. Again, I mentioned we used a couple of seed mixes, all native grasses, forests, shrubs, and we did just a sort of reduced version of that in an understory we already have established native vegetation. And then there were a few areas where we actually had quite enough soil throughout the time that we spread them. And then finally, all the open areas were harrowed after the seed and fertilizer to try and incorporate that. We hope to get the soil cover on the seed and hopefully prevent predation and desiccation until we got some rain. And then we went out and we monitored what the grant allowed was monitoring that first season right after we planted. So right after we planted in April of 2009, we went out and monitored again that fall, and then in April and October of 2010, we put out 20 line transects and we did a point intercept method for the cover, and then we did a 50 square meter belt transect and density as well. Just to show some pictures of what it's looking like. This is in 2008 before we did the mowing. This is in 2009 right after the planting. And in 2010, this is all arrowed. So we're getting very little Tamarisk coming back in, and we're getting the arrowed species that one of the species that the tribe is trying to manage for. This is a picture of that flood event that I mentioned. This is in March of 2010. This is the first flood since 1993. It caused quite a bit of soil movement on the site, but it also caused just a huge flush of seedlings, primarily early and backwoods, so the native shrubs. And it caused the total vegetation cover on the site to go from about 17% up to about almost 40%. That was mostly caused by a flush of annual blooms, but we did also see quite a flush of the native shrubs as well. There were some Tamarisk seedlings, of course, although not nearly as many as the native shrubs. This is again showing that flush by annual growths in the spring, and then in the fall, what you're seeing here are all salt bush and foliage. So Same sort of thing with diversity. Saw a huge number of species come in. This is sort of showing that weedy density. These are all of those shrubs that were flushed in right after that flooding event. Many of them did not make it through the hot summer, but it still have a higher shrub density in the fall of 2010. And the relative density of Tamarisk increased by about 10%. Our cottonwood poles, we only looked at a small percentage of them, but mortality was we only had about 12% survival on these cottonwood and willow species in total. However, our mesquites had very, very high survival. So, especially with the Scrubby mesquite, which is the most common species on the site, occurring naturally. So, some quick conclusions. After 2 years, our Tamarisk cover was about 10%. I've been out to the site since, although we have not had the funding to do actually informal monitoring. But Tamarisk cover is still quite low. Total vegetation cover after the second growing season is almost 40% for this kind of area, and most of it was native. We were seeing a lot of new wildlife in the area that we hadn't seen before. Quail, fox, rabbits, coyotes. Quite a few species coming in, a much more diverse community than we had before. We only saw 3 of the 13 seeded species. It's unfortunate. I think a lot of that being tied to the precipitation lag there. And again, while our containerized plants did very well, the full planting was not as successful. This is actually a picture that I just took this spring, though, so the 12% that survived, which is about 7 or 8 trees per acre, are still alive. And some of the lessons that we learned in this, the larger diameter poles tend to do better, not just surprising. But when we went back and tried to look at correlation, we correlated the water table with soil salinity, other measures as well, and the survival and the soil measures. We had hypothesized that it might have helped to cut the top, because a lot of the trees that did survive were actually cut off by a fever, and then they resprouted. As in this case. So thought maybe that would have helped to decrease some of that mortality. Because one of the things that we saw was by the time we actually got them in the ground, we did the April, and it starting to warm up, and so we started leaking out almost immediately into the definite development. So perhaps had we cut the tops off, we wouldn't have had quite as much leaf development early on, but the lesson learned really there is that we needed to be planting and it probably really would have helped if we had gone back out and been able to water. But we didn't really have anyone on the site who could do that or any way of getting water out there, unfortunately. So, like I said, the project was funded by the Arizona Water Protection Fund and the National Wildlife Federation, and I don't think I have any kind of question, but I do. Okay. Yeah, the question was, what was the total cost per acre? We had about $280,000 in grant money to do 40 acres, so someone can do the math on that really quick. I think that probably the 1% of regrowth that Tamarisk has to do with that we were pretty aggressive with. We did mowing and herbicide, and then we did 2 more herbicide applications throughout the 2 years. Also, it seemed like when we did have flood, we just had a huge flush of arrowweed and acrid seedlings, and we just weren't seeing that many Tamarisk seedlings. So I don't know if that was just competition or what's going to happen in the long term. Any other questions? Yeah. we went as deep as our auger would go. So we had no way of getting a larger piece of equipment that could go deeper than 9 feet into there because of the vehicle barrier. So we went down as deep as we could. In some cases, they were planted where they were actually in water. Other cases, the soil was only moist. If we got down 9 feet and the soil wasn't moist, we drove in the hole. But yeah, we did continue to monitor the wells while we were doing the monitoring for the next 2 years, and we were able to find a correlation between the water depth and the survival of holes. But there was sort of a patchiness. There were areas where many more holes survived and areas where no holes survived. Questions?